is a keyword in C++ used to give special characteristics to an element and can be used with the following: static variables within a function, static data members and member functions of a class, and static class objects. Let's begin by the behavior of a static variable in a function. Let's say you have a function counter, and I'm going to create a static variable within this function. So use the keyword static, specify the data type of the variable and name your variable. So count is a static variable of type integer. Static variable, if they are uninitialized, holds 0 as the default value. Let me use a cout statement and let me print an incremented value of this count variable. So this is the task of my function. It has a local static variable and it is printing the incremented value of the same. Let me call the counter function within the main. Now suppose if I want to call the function multiple times, I can make use of a looping statement. So for time being, let me use a for loop. So I have to declare a looping variable. Let me use the looping variable as I. Now I'll make use of the for statement. So initial value is 0 for the looping variable. And let's say my loop has to iterate 3 times. That is, I want to invoke the counter function 3 times. And the final part, that is the updation of your looping variable. Now put the function call within your for loop so that it gets called multiple times. Let me show you the output for this program. Then I'll explain to you the behavior of a local static variable. So let's build and run our program. So you can verify your output here. It is 1, 2, 3. So why? So your program execution starts with main. So for the first iteration, that is the I value is 0, 0 less than 3, my condition is true. So your function gets invoked. Binds with the function definition here. So since it is a static variable, uninitialized, count will have a default value 0. You are printing the incremented value. So 0 incremented to 1. That is your first output. So after the function execution, it comes back from where it was called. That is, the loop iterates for the second time now. So now 1 less than 3, the condition is true. So again it makes a call to the counter function. Binds with the function definition here. Now since count is a static variable, this is going to hold the previous value. That means reinitialization to the count variable is not going to happen. The latest value what the count variable was holding was 1. So from 1 it gets incremented, so you will get 2. That is why you're getting the second output as 2. Again, when the function gets called for the third time, it will retain the previous value of the count, that is 2. So from 2 it is incremented to 3, that is your final output 3. So further when it goes for the iteration, the condition of your for loop fails, so it comes out of the for loop. Now I'll show the difference what is going to happen when I remove this static keyword. Let's build and run our program and verify the difference in the output. So you have to initialize your variable here, otherwise you will end up with some junk values. So let me initialize it with a value 45. Now let's recheck our output. You can see the difference. The output is 46 all the time you call your function. So first iteration, when you call the function, it comes here, initialization happened. Count is initialized with 45. You are printing the incremented value, so output becomes 46. Second time you call the function, again this initialization happens. So initialized with 45. So again you're printing the incremented value. So 45 incremented once, you will get 46. So if it is a non-static variable, this initialization is going to happen each time you call the function. Whereas if it was a local static variable, it is going to retain the value between the function calls. Now let's see the behavior of static data members of a class. So let's create a class first. I have a class test and let me keep the entities as public. So I'm going to create a static data member. So use the keyword static and let C be a static data member. Now the property of static data member is that static data members are shared by all the objects of a class and they should not be initialized using a class member function, and they must be initialized outside of the class. So let's see how to initialize a static data member outside of your class. So specify the data type. So here it is integer. Specify your class name. Then use the scope resolution operator and specify your static variable name. Now you can initialize it with a integer entity. Now let's create an object to our class and try to access our static member function member variable through the object of the class. So test obj1. I'll create one more object, obj2, and let me try to access our static data member through the first object. So obj1.c, let me try to modify its value as 90. Same way, obj2.c, let me put a value as 34. Let's print and check our outputs. So obj1.c and obj2.c. Let's check our output. You can see our output is 34 and 34 because in our program we have tried to create multiple copies of static variable C for multiple objects, that is obj1 and obj2. But this didn't happen because static data members are shared by all the objects of our class, so you cannot duplicate them. Let's move on and see the peculiarities or the features of static member function of a class. Static member functions work for the class as a whole, and it has a feature that static member functions are allowed to access only the static data members. They cannot access the non-static data members or member function of the class. So let's create a static member function to our class. So use the keyword static, specify the return type of your function and then name of the function. So let's say we have a static member function void print, and the body of the function, let it be in such a way that it is printing static member function. To invoke a static member function, you do not need an object. You can call them through the class name and the scope resolution operator. So here our class name is test. Scope resolution operator, you can call your function by the name. So here it is print. So this statement will invoke the static member function of the class. Let's verify this. Yes, you can see your output. It's printing static member function. Means our function is getting invoked. Now I told you your static member function cannot access the non-static entities of your class. Let's verify it. Suppose you had a non-static member X in your class. If I try to access this X inside your static member function, you will end up with an error. Suppose I'm giving x is equal to 90. So by this statement, I'm trying to access a non-static member x inside your static member function. Let's build and run our program. This will not give you an output because you have an error here. What is the error? Invalid use of member test x in static member function. So it is very clear that static member function cannot access the non-static elements of your class. So now we'll see how to create a static object. It is very similar to how you created the static variable. So just use the keyword static, specify your class name, then the object name. So obj is now a static object of the class test, and it will have its life throughout your program. So these are the characteristics of few static elements. These concepts are very helpful in implementing the real-time problems, and we'll be seeing the implementations of the same in the coming sessions too.